Alright, this was come off the NRC page. Emergency diesel generator, the generator exciter voltage regulation 9.0. Generator exciter voltage regulation. Chapter presents major components of the electric generator exciter and the voltage regulator. Explains how they relate to the development of power diesel engine driven generator unit. Learning objectives. As a result of this lesson, you will be able to describe the functions of the generator exciter voltage regulator, identify the major components of the generator, how they interrelate, how to describe how a diesel engine output relates to the power demands of the generator, describe the function excitation system associated with the voltage regulator, identify the major components of the exciter voltage regulator system. 9.1 Generator Principle. The following brief discussion generator operational relationship with the mechanical load placed on the diesel engine. 9.1 Electrical induction. Electrical induction, the basic principle of the generator operation, involves the movement of electrical conductor through a magnetic field. Figure 9.1 show the principle being discussed in the section as as the conductor passes through the magnetic field. In the case of the downward cuts, each of these lines magnetic force flux, which causes the current of the induced into the conductor. Because the conductor has resistance is known from the Ohm's law of the voltage equal to the current times the resistance. Therefore, the voltage is induced between two ends of the conductor, and conductor is connected to the closed electrical circuit. The voltage therefore a voltage is also induced between two ends of the conductor. The conductor is connected to the closed electrical circuit. This voltage would cause the current flow. An amount of current flow is a function of voltage induced with the electrical resistance for the loaded circuit. 9.12 Induced voltage. Actual voltage induced for the conductor to determine the number of lines of pulse cut per unit of time. The two key factors of the effect of the magnitude of voltage induced. Speed at which the conductor moves with the fixed magnetic field, the strength of the magnetic field determine the output voltage of the speed of the function. Rotational speed of the generator and engine, and speed of the engine for the generator increase the voltage produced also increases. Since the operating speed of the engine generator is constant, in order to maintain the diesel frequency, another method of voltage control must be employed. Generator output voltage is most often controlled by regulating strength, flux, intensity of the magnetic field. Accomplished with the generator excitation system. The excitation system monitors generator output, regulates the magnetic field to maintain the desired voltage. As the load of the generator is increased, the increase of the current flow causes the voltage drop. The excitation system sends to the decrease of the voltage, increase the strength of the magnetic field for the return of the voltage to the desired level. 9.13 How the generator works. Figure 9.2 shows the principle discussed above. The implemented in the machine produce a voltage implementation as a U-shape provided with a gap between the open ends of the U. The coil wire is wrapped around the legs of the form to produce the magnetic field across the loop of the wire. Loop exists for the armature onto the two slip rings. The slip rings are contacted by brushes connecting the generator to the outside electrical circuit. The engine of some of the other primer movers is connected to the armature, causing the rotate inside of the gap. The field coils energize the established magnetic field and flux in the gap. The armature is then rotated. The voltage generated by the armature and the slip rings and brushes conduct the voltage out to some load A. Figure 9.3 shows the blow up of the armature in the gap. The armature is rotated with the initial position. No voltage is created because the magnetic flux is equal to but opposite of the both branches of the loop. This is shown with a part of the diagram labeled the armature is turned with a position 90 degrees from the first of the two. The ends of the loops actuated upon the manner where the voltage generated at each end of the loop are additive, is shown with the figure quarter cycle diagram. Peak output voltage generated each cycle. The point of the armature continues to rotate again with the gets the position with no voltage generated shown. Half cycle diagram rotation continues the voltage again. The generator of the close examination of the wiring out of the armature reveals that the connections have been inverted. This resolves the opposite polarity of the voltage. The diagram at the bottom of the figure shows the resulting buildup of the decay of the opposite polarity, buildup of the decay again. Through two cycles of two rotations, armature of the resulting voltage builds up with the decay and the sinusoidal wave that is defined with the alternating current or AC. The basis for the single-phase alternator, two other sets for the coil with the offset with 120 degrees for the connecting of the slip rings would form the machine generating a three-phase AC with the basis for all three AC three-phase generations. Instead of using two slip rings, a single ring with a slip in into two segments where either the armature rotated with the would-be build up the decay of the voltage before the split ring would reverse the connection on each half of the rotation. Slip ring configuration is commonly referred to as the communicator. This would be resolved with a machine that puts out the pulsating DC current by combining a great many of the poles in the same number of segments. Our armature commutator almost for the DC output would produce. This is the principle of the DC generator and motor. AC alternator described above has a number of problems. The armature and its slip rings have to handle all load current produced by this generator. Brushes and slip rings restrict the amount of the current that can be handled and eliminated with the problem designed with the construction where chainsaws that the small excitation current now goes through the brushes. Slip rings rotating armature field with larger AC current induced with the stationary stator windings transmitted with loads by solid connections. Same principle also applied with the AC synchronizing motors. The other little difference between AC generator and also AC synchronous motors is a matter of the driven system and an electric motor of the engine-driven generator. This also applies to the construction of generators. These machines are very often also called the alternators, in so much that the voltage and current are alternating. Three-phase generator alternators, simply the three single-phase machines interlace one another about sharing the same rotor assembly with the brought out with the connection of each phase into the electrical system, result interlacing with the alternate windings. The shown voltage trace shown in figure 9.4. The upper part of figure 9.4 shows how the current in each and any phase of the produce the power. Left the most diagram shows the current in phase with the voltage of this case of the power with a factor of 1.0 a unity, the real power of the kilowatts for the cost of the apparent of the power of the kilovoltage ampere. This term discussed later with the current is not in favor with the voltage of the lesser power factor of the kW kilowatts of the less than the kilovoltage ampere. Kilowatts is still a phase of the voltage phase within the voltage of the kilovolt voltage ampere has shifted slightly due to the shift in the current that introduced with the kilovoltage ampere resistance will be explained later. Generator construction figure 9.5 shows for the cutaway a typical generator consists of the shaft of the mount of the hub more than often called the spire. The spire may be detached with the shaft of the breast fitted or with or without keys by the flange or bolting. Spiders has a slot in which the field hole pieces are attached together that makes up the rotor of the rotor assembly. Usually also includes the slip rings used to convey the field current into the field windings. These windings are wrapped around the pole piece of the view of the rotator and shaft as shown in figure 9.7. Spaces consist of the special steel stampings called lamination slabs over the whole of the stator windings. Stator core has a space between some of the laminations through the air which air is forced by the fans of the rotor assembly. This provides cooling for the stator core and the windings. The steel frameworks support the line of the stator core assembly. These steel frameworks are also usually support the bearings in the generator. Some of the generators are equipped with two dedicated bearings on each end of the generator rotor assembly. Others are supplied on an outboard bearing. Far end of the generator, engine bearing supports an other end of the generator. The wiring of the stator slots are grouped in section number. Each of the phase match with the number of the poles on the rotor. The various sections of the wire together the peripheral of the stator. The end of the groups are gathered together with the brought out of the generator electrical connection box. Figure 9.6 shows the assembled generator ready to installation of the engine. The particular machine has shaft-driven exciter unit, small diameter cylinder shown on one end of the generator. Figure 9.6 through 9.22 show the various parts aspects of the assembly of the parts of the generator. Through 9.3, generator terminology, generator frequency, 9.3.1. Another key element output of the generator frequency is the function of rotational speed, or RPMs of the engine with the number of the poles magnetic field of the generator shown following equation. This operating speed of the engine generator produced the number of poles must be increased to achieve with 60 hertz and EDG, or operating at 400 RPMs would require twice as many poles of the unit operating with 900 RPMs. One design number of poles in an alternating current machine is fixed. So you have your F equals M times P over 120. And so number of poles over 120, which would be your AC amount of hertz, would be a fixed force frequency. F shows that the frequency, P is the number of the poles, N the generator speed, or RPM is shortcut of the 60 hertz power generator. The number of the generator speed is 72 RPMs at P over P to P, therefore P is 72 RPMs over the number of over the generator speed. All generators have an even number of the poles that the engine running at 900 RPMs would have, though 8 poles of the generator produce the 6 hertz power. 932 machine mechanical loading. Electrical conductors move through the magnetic field of the generator. That opposing magnetic field is created around the conductor's opposing field resist the movement of the conductors through the generator magnetic field. The physical force or power provided with the diesel engine must be sufficient to overcome the resistance of the opposite field in order to achieve the desired voltage and frequency. as the load of the generator, increase the form with the increase of the current demand with the excitation system, increase the density of the magnetic flux, increase the current with the generator field, with the increase of the resistance to the movement of the conductors through the field. As the result of the generator induce the voltage, increase the monetarily until the excitation system compensates to return the voltage to the previous level. Since the load was increased with a relatively constant voltage, the output current, or hence output power of the generator, must increase. The power demand is also felt on the diesel engine, which is trying to maintain the speed constant as the load from the generator increases. 9.4 Generator control. Alternating current. AC generators for the type of driven with a high horsepower diesel engine with a nuclear application with a reliable, stable, accurate means with licensed technical specifications. Stipulate voltage frequency limit during the fast starting subsequent loading of the load register, rejecting testing in a normal operation for a generic EDG. Typical voltage frequency limits are 4160 at plus or minus 420 volts at 10%, 60 plus or minus 1.2 hertz at 2% respectively. 941 frequency control. Generally, frequency control accomplished with the engine governor with the sensing the speed change with the desired speed set point with the governor adjust the fuel of the engine as required to keep the engine operating with the desired set point speed. 942 the voltage control. Large AC generator with the combination exciter voltage regulation system with the main generator field current under varying electrical load with the basic voltage regulation system designed to automatically regulate the generator output terminal voltage losses closer to the tolerance for the specified value of the generic regulation system is closed loop feedback system in which the generator output voltage is automatically compared with the reference voltage of the error signal is used with the chain with the generator excitation system. Excitation is discussed a little more in detail in figure 9.5. Generic ADG must be capable of emergency diesel generator must be capable of accepting loads assigned by the auto sequencing system, maintaining the voltage at minimum 75% of the nominal voltage, 25 voltage jet. The emergency diesel generator voltage regulator is essential for the correct with the emergency diesel generator output voltage is powered by a Class 1E power supply with a test for the satisfactory operation during the emergency diesel generator surveillance testing of the voltage regulator and operable. The emergency diesel generator is inoperable. The generator exciter varies in strength with the generator rotor field current either with automatic during auto sequencing manually with the control room and the emergency diesel generator control panel. Or the generic FSAR specified with the governor voltage regulator with a comparison with the testing with the benchmark can be demonstrated with acceptable performance of the whole subsystem with experience with the major load changes. The testing is incorporated with the technical specifications surveillance items. 943 Generator rating. The discussion included the emergency diesel generator electrical character with electrical load. Several parameters associated with the AC machine that define with these include real power, reactive power, apparent power, power factor. Generators are normally rated with a kilovolt ampere. The design to produce that is normally a power effective with 0.8 per NEMA 1 standards. Some of the generators are rated at kilowatts, but when the power factor comes, must be also stated. 943 real power kilowatts. Real power alternating current refers to the true electrical power that is converted with the mechanical engineering such that the motor-driven pump of the power is measured with the watts, the kilowatts, or megawatts, MW, for large electrical systems. Reactive power, or KVR. Most electrical systems undergo the change of the voltage current for either the capacity of the induction for the DC system, and then only important with the significant change of the AC power for the continually changing of the voltage inside the induced and or capacity become the more important with electrical power than either the AC machinery, motor, generator, transformer to the create of the magnetic field of the voltage induced in each of these enable these machines to operate with the magnetism power, which is stored energy for the AC system. Reactive power, current component of the power acts as 90 degrees from the real power kilowatts. Reactive power is measured with the voltage amp reactive, or voltage amp reactive, or VAR. For a high voltage system, reactive power may be measured with a kilovoltage active reactive, or megavoltage active reactive. Apparent kilovolt amperes. Its name is applied with apparent power with the power with apparently required with the input drawn with the AC system. Apparent power with the voltage amp with the kilovolt amp with the megavolt amp is determined with the multiplying the voltage time and the ampere time to the square root with a three-phase electrical system, then dividing the result by the 1,000 kiloamperes of about 1 million megavolt amperes. 9434 power factor. The power factor ratio, real power kilowatt, apparent power kilovolt amperes, is a measure utilization input power of the system. The equivalent of the typical power factor of the rating of the generator for NEMA standard is power factor of 0.8 or 80%. For the actual example of the generator part Generic plant with the FSAR of the standby emergency diesel generator rated with 4,000 kilowatts. Provide real power input generator and enough magnetism power for the generator to rotate stay with the generator is rated with the apparent power of 55,000 kilovolt amperes. Alright, 9435, relationship with the kilowatt, kilovolt, amp to kilovolt, ampere, reactive and power factor. The relationship between kilowatt, kilovolt, amp to kilovolt, ampere, reactive and power factor allow the use to calculate one of the known at least two of the other. relationships is described as followed with the following formula. Kilovolt ampere squared is equal to kilowatt amperes plus the kilovolt ampere reactive squared. Power factor decimal kilowatts over the kilovolt amperes. Power factor percentage multiplied with the decimal by 1%. Note that the relationship of the kilowatt, kilovolt ampere to reactive with the kilovolt ampere is the same for any of the right triangle of the Pythagorean theorem. Also note the triangular relation between the three factors can also be solved with any of the two are known. This includes the power factor such for the more power factor given the relationship between the kilowatt kilovolt ampere known as the kilowatt kilovolt ampere and power factor one can get the other from the third. Kilowatt usually measure the displacement of the meter with the kilovolt ampere can be obtained with the taking the voltage average of the three phase of the current average of the three phases of the multiplying them together, then multiplying the result of the square root of 1.373, or for phase of the power system, dividing 1,000 to get the kilovolt amp with the kilovolt amp the reactor made a display on the meter, as well as the power factor being displayed. There's no need for the direct measuring of the kilovolt amp the reactive with the power factor for the others than special meters for the purpose of calculation using the above formula. The power factor meter the least accurate of any of electrical parameters and is so far the more accurate to solve the triangular relation between the kilowatt and kilovolt ampere is shown in paragraph 4. Inconvenient with this point, emphasize the principle applied with the engine driven with the generator system. The governor on the engine for the control of the response for the kilowatt loading of the generator, voltage regulator exciter system controls and respond with the kilovolt ampere, thereby kilovolts ampere reactive loading. Two controls of the devices are quite independent of the other voltage diffs. Result of the generator exciter with the voltage regulator the characteristic of the result respond with the frequency the depth of the result of the engine governor characteristic of the respond with the engine nothing of the kilovolt amp of the reactive loading except for the main influence the efficiency of the generator of the relationship with the engine. The kilowatt loading of the generator is converted with the engine horsepower required with the following relationship. The BHP engine of the generator with the kilowatt times 100 over 0.746 generator efficiency and percentage. Excitation voltage regulation. Every power generator system requires the sum of the mean of the control of the voltage and current produced with the machine with the output of the generator is normally controlled with the current with the field of the generator, the speed being with the constant with the set frequency of the various excitation system possible, but they also usually include a system sensing controlling the generator output voltage. 951. Type of the excitation system. Excitation system vary with the simple of the rare rather than complex system will consist of the battery supply with excitation power to the generator field, field along with the rheostat control of the amount of the excitation current with it being managed manually by the operator. System is generally not acceptable, therefore some of the means of automatic control of the desired may consider the automatic rheostat, such as the old Westinghouse rock arm solar shaft design worked and wasn't fast, however the drooping voltage regulation, but it was simple. Most modern excitation systems involve the electronic voltage sensing with the regulation of the relatively fast and accurate, with many of the excitation systems consist of the excitation generator driven by an engine either directly or by a system of the pulley or belt to the excitation generator that puts the power with the voltage regulator control of the generator field in such a way that the main generator field is under control. Many commercial systems use the term the brushless exciter. The brushless exciter system is an alternator generator mounted on the end of the generator shaft that's driven along with the main generator. Permanent magnet field excites the alternator as if the rotator of the alternator output goes through the diode bridge for the converter for the DIN to the DC. Fed with the generator field through the wires running along with the shaft between the alternator's output section with the main generator field. There are no brush of the type system. This determines brushless exciters. Current winding included in the permanent magnet field with the control of the output of the exciter alternator, thereby with the magnetic generator field. There are a few of these systems nuclear stations that are not as fast and responsiveness as the electrical system discussed below, but not limited power capability over response low because the system has to operate with the two sets of the magnetic exciter alternator and the main generator field. Most excitation system used with the nuclear power station is either the series of boost of the full electronic static or resistor voltage regulator system. These are more similar but different with the mode case. They be explained with the excitation system shown figure 923. Excitation output with the DC voltage type that's fed through the bundles of slip rings into the main generator field windings. 952. The excitation elements of the electronic static type excitation system. Figure 923 shows the elements of the typical modern electronic excitation system with a difference between the series boost and the static exciter voltage regulator. And the basic elements of the same in the both the system difference will be explained in each of the sections of the system is explained. Alright, figure 923 shows the generator with the farly left of the load lines with the right with until the final path of the generator output circuit with the breaker on the load. Each of the load exists with the generator that goes through the primary side of the power current transformer. Secondary side of the transformer feed the power the excitation into the exciter package. The most amount of the exciter system has the power current transformer to supply with some supply of the excitation current required by the generator field. So once again, you have your series boosters and static exciter voltage regulator. Alright, properly sized PCT supply power to the excitation direct portion load of the generator. The generator excited with the system required with 1 to 2% of the generator output power. If the load lines continue beyond with the PCT with the connection with the connections are a power potential transformer. So if there's no generator output current with no load on the generator, there must be some of the source of the power of the generator excitation where there's no load. Personal power potential transformer supply with the power of the generator. The excitation with the generator is not low, but this load is continuing to beyond with the power potential transformer, the connection, another power transformer connection, sensing the generator output. This is fed with the voltage regulator suction as a sense of the generator output voltage. Beyond the sensing of the power transformer connection, there is another current transformer, CT, sensing the amount of voltage V with the current, assuming the voltage is constant. This is adjusted the voltage regulator output with the unit being parallel to the grid infinite bus in order to control the reactive power component of the load. If the current was parallel with the voltage regulator receives some sense of load on the system, equivalent to the drop function with the governing system principle is variously called with the current. Compensation, load compensation, parallel load sensing voltage droop. Function is usually switched automatically with the diesel generator's emergency mode, but is required with the parallel operation. If the circuit were left in an emergency mode, there would be a slight change of the voltage as load as is put on the unit not desired in the isolated emergency mode. But the terms used for the switching of the control function usually referred to as the unit without current compensation and parallel with current compensation. Voltage regulator receive the reference signal of the operator system with the testing of the voltage. Maintaining the voltage may be modified with the current with the compensating circuit with the exciter. Set with the parallel operation case with the reference input with the regulator with the compare with the sense of voltage input. Voltage regulator output change with the restore with the generator's output voltage back of the reference voltage input. Output signal with the voltage regulator control element the power section exciter system. The section is attached to the power potential transformer. The properly sized power transformer is controlled with the output of the voltage which need for the current compensation. Generally, there are two methods of the control of the power section. These are either the series boost exciter and the transformer that have the third hereditary winding. The power potential transformer are likely normal. Transformer to hereditary winding is not turned on. However, if there is current with the hereditary winding is called, the transformer becomes saturated from the point of the current transformer from which the primary power potential transformer on the secondary is and can be restricted, thus output current can be controlled. The transformers are therefore called saturatable reactors. In the case of the static exciter voltage regulator type exciter, the amount of current of the power section with the control of the turning off, the holding of the firing of the silicone control rectifiers. Similar electronically, after the large amount of the power is required with the silicone control rectifiers are fired early in the voltage cycle. If less power is required with the silicone-controlled rectifiers are fired later, no power is required within the voltage overshoot situation. Silicone rectifiers are not turned on. This means the controlling of the no-load excitation powers in such a system. The power from power to section over the rectifier section where it joined with the power of the power contact transformer. The rectifier converted with the AC/DC the current with the sound with the generator with this field is shown. The usually voltage meter with the amperage meter in the field circuit show the field connections can be monitored. The generator field can accept only a direct current supply with the generator as a fixed resistance chain only with a slightly by the temperature. Therefore, the field vendor voltage current and proportional is helpful in troubleshooting of some of the exciter generator problems, such as detecting short or ground in the generator field. There are a number of differences in some of the excitation techniques, which are worth mentioning. Westinghouse GE exciters are power section output with the pneumatic power control transformer contribution rectified separately with the joined together with the DC field current and a ballaster or Portex system. The power section of the power controller transformer contributions are joined with the AC side rectified after they are joined. The Portex exciter is the shunt type regulator that this is all of the power of the generator with the exciter goes through the generator field circuit or silicone control rectifier that are connected with the parallel to the generator field to shunt with the proper amount of the current around the field in order to control the current that goes around through the field. Other than these differences, with most exciter of the system is more likely than different with all the contain the basic elements shown in figure 9.24. There's generally some feedback from the exciter output section of the voltage regulator section, so that the voltage regulator anticipate what it needs to in the next step of the needs to help to stabilize the regulator. Most regulation systems without feedback system tend to turn all the way off. This is not desirable. Therefore, feedback helps the regulator know how much excitation is being put on some of the gauge that against the error and anticipate that the problem is nearly resolved at L. These accelerators are self-sustaining. This is takes the power they need for the generator output. They require no external power, normal operation, but also mean that they would probably not start for themselves when required. Therefore, a means of starting the excitation process has to be provided. This is done by field flashing circuit that also shown in figure 9.23. The circuit consists of the battery, maybe station batteries, and a switch. The switch is closed when the switch is closed when the system signal that start up usually upon engine achieving a certain speed, and the switch is open when the voltage regulator senses the generator voltage has built up to a certain value, usually 65 to 75% of the rated voltage inside of the rectifier section. Circuit usually include the diode block reverser current from the exciter back into the batteries. Usually some of the resistors are included to limit current available from the batteries because a small current is needed in the generator field to get the generation started. Most of the modern excitation systems have the capability of putting out the immense amount of power if needed. The sustained related load may be not to take much power to start a large motor load. May tax generator exciter system. Most of the modern exciters are capable of putting out 3 to 5 times or 300 to 500% of the generator's normal full load excitation current. This is called field forcing. The voltage dipping is caused by starting a large motor primarily with the function of the generator characteristics, specifically with the transit, subtransient, resistant reactance. However, the rate of recovery of the percent of the voltage dip can be influenced with the response from the field forcing the capabilities of the excitation system. Alright, 953 brushless excitation system. Brushless excitation systems has an advantage of not having the brush of the transmit of the current of the generator field through the slip rings in the brush. Figure 924 show the schematic diagram of the typical brushless exciter system. Your brushless exciter system consists of an exciter generator mounted with the generator shaft, usually outboard with the generator bearing diode plate with attaches to one side of the exciter rotor with a strip of the chain of the AC output of the DC output of the fed of the whole of the exciter shaft of the main generator that excites through exits from a passing from the rear of the generator housing with the connecting with the rotating main generator field bit windings. There are no slipping of the rings or brushes. Field exciter generator stationary with the housing of the mounted onto the rear end of the main generator. An alternator of the may be mounted with the outboard of the exciter generator. This unit would have the permanent magnet rotor with usually mounted on the back of the generator shaft of the exciter. Winding of the alternator puts out an AC current voltage regulator with the term of the AC input with the DC output with the control of the ultimate control of the current of the main generator field. Its unit, if the unit does not have the permanent magnetic alternator, another source of voltage regulator must be provided with the number of cases that may be from the battery. In other cases, that may the generator output reduces the voltage by the transformer. In the last case, the sense of the voltage source is not available, the emergency diesel generator is being started by a battery is used as a flash system until the generator voltage has built up into a rear generator voltage condition, similar to flashing the field of the static exciter system discussed above. Alright, 954 digital voltage regulation. The only section of the installation system that lends itself with the digital control is a voltage regulator, where there are some of the advantages of the digitizing the voltage regulator. The purpose of the better voltage stability during isolated operation, power of the emergency busing, and controlling of the reactive power with the power factor light tighter in parallel with the offsite power of the system, effectively to be a small the comparison with the existing analog system. Voltage regulator operates basically analog inputs in the case of the Basler series boost system used at most plants. The output of the is analog, but there is little advantage to insert the digital component of the bridge between input and output. When it becomes responsive to the voltage dip, the coil with the starting large motors is primarily influenced by the characteristic level of the generator would be not appreciably influenced by having the faster, more complicated voltage regulator. The more components in the system, the less reliable the system becomes. 954 digital voltage regulation. Only section of the excitation system that lends itself to digital control is the voltage regulator, whereas some of the advantages of the digitizing voltage regulator, the purpose of their voltage stability during isolated powering over the emergency bus, of controlling reactive power for the lighter, tighter, and parallel offset power systems, effect would be small in comparison to existing analog system. Voltage regulator operates basically with the analog inputs. In the case of the Sears booster system, the output is all along analog. There is a little advantage to inserting digital components in between the input and output. When it responds with the voltage dip, the coil of the starting and large motor, prominently influenced with the character of the generator, would be not be appreciably influenced. Having the faster, more complicated voltage regulator, the more components of the system, the less reliable the system becomes. And that was actually spoken twice. 96 generator output breaker. The 923 also show the main generator outbreaker at the right end of the diagram. The generator outbreaker will connect with the generator to class 1E emergency bus. When an emergency start signal is received, the emergency diesel engine's generator starts, comes up with the rated speed of the voltage of the output circuit breaker with its clove. The automatically auxiliary contact with the circuit breaker to provide with the signal to the load sequencer to connect with the emergency load with the proper sequence over the time period of approximately 30 seconds. And in the event of the unit being started with the surveillance testing, output breaker is closed manually with the plant operative to bring the unit with the synchronization of the offset power system. The operator must closely match the frequency of the generator to that of the offsite power generator, slightly higher than the offsite frequency, so that the unit will assume some load when the output breaker is closed. Voltage must also be closely matched with a slightly high so that the voltage kilovoltage ampere reactive loading will be outbound rather than inbound. Synchroscope is typically used to bring the unit into synchronization. The system may also include synchro check relays to protect the generator output breaker from being closed with the unit not synchronized properly. Alright, 97, the generator different protection. The generator requires very little monitoring normal operation. Output voltage current, field voltage current, the state of the temperature of the perhaps bearing of the temperature oil level would be about the extent of the required monitoring. However, there is one item that is required with the Nuclear Regulatory Commission regulations that not only be monitored by such a fault as detected on unit must be immediately shut down, not only the generator but the engine as well. A system set up with the monitor of the current of the generator, the neutral side of the loss of the current in each of the phase of the output load side of the generator. If one of the phases were to go round, if the phase-to-phase fault develops, input of the output currents would not match, indicating a problem exists within the protected area of the generator. The normal distributed current in each phase of the generators are balanced. Determine that the current going in the load of the generator, the current with the current generator loop are same as if it normally would be. The detection system set up with the shown figure 925. Know that there is a set of current transformers of the installed with the line into the current generator of the neutral side of the generator windings. These are like a set of the control current transformers installed beyond the units of the circuit of the breaker of the monitor of the currents going through the generator load. This diagram shows the interconnection with the current transformer with the CT4C for the phase of the system. This is like a device. The circuit breaker is each phase of the A, B, and C. Circuit induced the device is called the 87th trip relay with the differential relay with the current that becomes the unbalanced due to the significant single phase loading of the mismatch becomes of some of the generator output current going in the ground shortened to the another phase that causes the current through the coil of the 87th relay. If the current is sustained level above the 87th relay trips that point with the relay execute its actuate its contact. When the contact operates, the pulse of the current with the latch coil onto the 86 strip device shown figure 925. When The 86 strip device coil with the inner drive the latch for the holding the 86 strip device handle in the reset position is pulled. Solenoid action move of the 86 strip device to the trip. The position contact with the 86 strips device closes circuit in the engine of the generator control system shuts down the engine with the shutter off of the generator excitation system. 86 strip device must be manually reset in order to restore the emergency diesel generator unit to the operating status. Alright, prompt shutdown of the generator, minimize the damage of the generator, can prevent the generator destruction, prolong the operation with a high fault current. Prompt shutdown of the engine may prevent the mechanical damage of the generator with the engine with the vent of the generator component with expand with the separate with the causing rubbing or seizure of the generator rotor with the state of the important of the note of the each of the phase of the generator is mounted with the and 87 of the relay with the operation of any of these relays. Because the 86th device to trip which shuts down the general. In conclusion, the generator differential protection with the required with the license of the FSAR with the technical specification required with the NRC with the regulation guideline 19 IEE 387. This one and two conditions will shut down the emergency diesel generator under all circumstances. The other mandatory shutdowns from the engine going into overspeed condition and other shutdowns may include only applied coincidental logic. Alright, 971 generator mounting and protection. A panel for controlling monitoring usually found in the nuclear power and various meter relay with the trip mechanism mounted with the panel that give the operator beam with the monitoring with the generator's operator performance. Typical the following meters will be in present. Phase current, phase voltage meter with the phase selection switch, field volt amp, the meters, kilowatt, kilovolt amperes operated with the power factor meter, synchronized scope and synchronizing lights, and frequency meter with the engine tachometer. Typically relays and trips would include a differential fault, 86 strip switch, lost field, ground, overcurrent, over voltage relay, under voltage reverse power, and under frequency relays and trips. 972 generator stressors. Generator subject to stress due to the normal currents running through the winding of the avoid undue stresses. There are some operational conditions which should be guarded against if all possible. They either add extra stress to the generator that may cause the generator damage. These fall into the two basic categories with some items appearing in about both categories. 721 electrical stressors primarily for the stator. High sustained currents, high motor starter, load currents, parallel auto phasing, high operating temperatures. 9722 mechanical stress primarily from the rotor. Dynamic loading and engine problems suddenly applied fault, current loading, central figure rotational loading, high operational temperature, parallel out of phasing, armature not concentric with stator, vibration out of balance, out of alignment. The above mechanical stresses may be involved with the engine as well as the generator. Alright, 9-8, generator and connection alignment with the engine, figure 926. One of the exercises of the student will participate while within the school to check with the crankshaft, the deflection with the last of the crank throw of the engine, figure 926. Show the dial indicators mounted between the check of the crankshaft with the throw of the determinant of the crankshaft with the straight with the procedure for the crank alignment is commonly known as the crank web deflection crank alignment. Crank pin journal also considered to be the fixed length. Crankshaft is not straight through the throw. As with the crankshaft rotate, the crankshaft's webs go through the winding of the accommodated with the bending of the cracking when this causes the crank cheeks to go and being moved more open to the being more closed as shown with the lower with the left portion of the diagram. The crankshaft attempting to bend is in the section shown as the area of the high stresses. If the crank continue to bend and deflect during each rotation, it can induce high enough stress to fall over time. It's necessary to change the situation to minimize the bending and the flexing of the crankshaft, particularly through the last throws. The lower right diagram shows the situation where the sum of the weight of the generator shaft of the rotor are being carried by the last bearing of the engine. The bearing is next to the last throw on the crank of the upright, with the lower diagram showing the bending of the last throw as a result of the generator rotor weight to elevate the problem, usually with the rear bearing of the generator's raised so that the generator engine shaft is straight through the last bearing straight into the last crank throw. While this diaphragm exaggerates the actual situation, it's usually only necessary to raise generator bearing by a few thousandths of an inch. It may also be necessary to shift the generator bearing sideways in order to have the crankshaft straight in the horizontal plane. Once the generator bearing of the rotor are properly set with the relief of the crank, stress and strain of the generator stator must be protected to raise the back of the rotor position, equalizing the air gap between the stator and the rotor. This is usually done by shifting the generator with the dragstring screw. For this, install the shims under the generator feet and before tightening the generator to the foundation of the skid. Details how to perform a crankshaft alignment will be covered in the hands-on exercise. This shows figure Figure 191 shows the conductor in a magnetic field. A direction current for excitation fields through the load. Simple AC generator. Start 1/4 cycle through half cycle, 3/4 cycle. Current phase and voltage. Current phase and wattage, voltage, amperes, kilovolt, amperes, power, kilowatt, power, kilovolt, amperes. Three-phase power, voltage generation. Alright, back out of this. This is what I really wanted to look at. Alright, you have your stator frame, your stator laminations, your stator winding, your air gap, and then your field pole piece, rotor spider, slip rings, shroud, rotor shaft, fan blades, winding end turns, and bracings. This is a picture of an OP engine generator assembly under test. 9.7 shows a complete rotor assembly, coupling in shaft view. Figure 9.8 shows the generator shaft coupling in view. Figure 9 shows the rotor spider hub. Figure 9.10 shows the field pole wedges. Figure 9.11 shows the field pole blocking. Figure 12 shows field pole with the armatizers. Figure 9.13 shows field wiring to the slip. Figure 9.14 shows the slip ring assembly. Figure 9.15 shows winding coil. Windings installed in the stator. 9.17 coil tying and bracing. Lead cable terminals 9.18. Complete stator assembly. Bearing housing assembled rotor. Brushing, rigging, and slip rings. This shows your exciter block system is the starting with the ground and generator going to the current inputs, and then it goes to rectification transformer. You have your generator field, power can detector transformer, power potential transformer, power transformer, rectification, AC to DC, power voltage regulator, output breakers, voltage sensing and voltage input, feedback, field flashing, battery, but the generator, rectification, AC, DC, reference, current load control, stoppage, and typical modern excitation system, generator, ground, currents, inputs, field generator, field flashing, rectification, battery, feedback, power generator, reference, current control, stop, voltage input, voltage sensing. This shows your load busing between A, B, and C, unit breaker control transformer, 86 trip relay, load side ABC, generator ABC control transformer, 87 relay, neutral side, and sorry, I didn't know that was straight. Alright, what you have is your main journal, crank web, crank pin journal, indicator high stress, main journal, crank web, crank pin fixed links, X main bearings, engine link, last crank throat, generator, rotate, weight. And your hands-on session for it's not going to be put together right now.